of the quadmester for math anyways. So again, we'll have our test on Tuesday, which would be the last test number 7. And then that's it. All right, so here we go. Surface area of a sphere. We got a ball here. All right, and this formula compared to what we've been doing is not that bad because all we need is the r squared, right? We just need the r, the radius of the sphere. So here we go, 4 pi r squared. That's our formula. So in this situation, again, here's our radius from middle out to the edge. So I'm going to label that. And again, our formula is, whoa, that's going to be big letters. Surface area is equal to 4 pi. Not sure which one of you showed me that you guys did that on your test, but I copied you. And then r squared. All right, so my radius is 3. I'm going to substitute into my formula. So I got 4 times pi, which again, 3.14. My radius again is 3, and I have to square it. All right, and as always, bedmiss, right? You got to do bedmiss. So I'm going to do the exponent here first. And so I have my surface area is equal to 4 times my pi, 3.14, times 3 squared. 3 times 3, 9. All right, and then lastly, surface area is equal to, I got to multiply those 3 numbers, 4 times 3.14 times 9, and then put some units on it, and I'm getting 113.04, and we're dealing with centimeters. And again, we're looking at how many squares it would take to cover this particular ball or sphere. So it's centimeters squared. All right. So again, that's one of our easier formulas that we've had considering what we have been doing. And so again, there's my example 1. So you know I'm going to have to try to throw a trick in there. So here we go. See if you can figure out what the trick is. There's always a catch, right? I always make a catch the second example or in there somewhere. All right, so we got 4 pi r squared. Anybody know what the catch is here?
It's diameter instead of
radius. You got it. All right, so again, our radius is going to be half of that, which is a 5. All right, so I'm just going to do the same thing because that's the trick is off the start, or the catch, I would say. So we get 4 equals 4 times pi, which again is our 3.14. And our radius is 5. And squared. All right, there we go. So again, follow bedmiss. Got to do my exponent first. So we have our surface area is equal to 4 times a 3.14. And 5 squared. 5 times 5, 25. All right, and lastly, all we have to do is multiply our 4 numbers, put some units on it. So 4 times 3.14 times 25. Let's see, actually I can do this one in my head. 4 times 25 is 100, and times 3.14, we just move the decimal place 2 to the right. So it'd be 314. Talking about meters and squared. There we go. All right, so that's our sphere. What else? We got one more shape left because, again, we're not doing pyramids. I keep getting that question. We're not doing pyramids this time out. All right, but we are doing cones. All right, well, this formula is a little bit more because, again, there's 2 pieces to it. We have an exponent. The 2 things you need to know. The radius, got to plug that in twice. And here's something that's showing up, the old slant height, S. So that is the red line I'm drawing on the cone. All right, so that's our height, but at a slant. We still do have the height, but we don't need it for this formula. All right, so my waffle cone. I missed that place. They closed down on me. All right, so I'm reminiscing here. All right, so again, here's our formula. We have our surface area is equal to pi r squared. All right, plus the second part here, which is pi r times s. All right, so I look at my diagram. Again, just lining things up. Even though this is an upside down cone compared to our diagram, again, our radius from the center to the outside in the circle part. So there's our r. Our height is from that circle part straight up to the cone, or straight down in this case. That would be our height, which we don't have, but we do have our slant height, which is 15. All right, so, well, I don't need h. Great. So I'm going to plug that information in. This is pi r squared. Make sure I put that in there because I don't want to mess it up. Okay, so let's plug in our values. All right, so we have surface area equals pi, which is, again, our 3.14. Our radius, again, this is why I label diagrams 9. So put a 9 there, and I'm going to have to square it. Maybe I'll try a little arrow here instead of writing it in. Can't find the arrow. Okay, scrap that idea. All right, plus pi rs. So we have, again, 3.14 times r, which is 9, times s, which is 15. Okay, there we go. And I don't want to forget this squared on this 9, because that's what I got to do next, right? Bedmas. So that's the most common mistake I see in this this type of equation is following Bedmas. All right, and so we got 3.14 times 9 squared, and 9 squared is 9 times 9, which I know is 81 actually. All right, plus, again, I'm just rewriting this stuff out because I'm not doing anything with it yet. It is coming. All right, so again, I follow Bedmas. And so now it's time for the multiplying. So I got 2 parts I got to multiply, here with the 2 numbers and here with the 3 numbers. So I got 3.14 times 81, which is 2.54, 0.34. All right, and then I have my second part that I have to multiply. 3.14 times 9 times 15. I'm getting 423.9. All right, then lastly, finally, we get to put the 2 numbers together, put some units on it. And so, again, you guys have been really good about putting your units on things. I hate taking away half marks for something like that, but unfortunately it's necessary. And I don't want to lose a half mark here, so I put in the squared. So we have 678.43 centimeters squared. All right. So let's try that again. But of course, hey, you know how I'm working here. Example 2, time for the catch. All right, so have a look at the diagram. I'm going to write out my formula here and see if you can figure out what the catch is on this one. So I got, again, my surface area is pi r, and I'll put the squared in, plus pi times r times s. Squared there. All right. Can you figure out what the catch is in this one?
There's no slant height.
No, there isn't. Right there. But how? Somebody else other than Jocelyn. I believe that was Jocelyn. I recognize your voice. How am I going to get that S? How am I going to get that S? How's that going to happen? You can even write it in the chat if you can spell it. Yeah, there we go. Pythagorean theorem. Thanks, JD. All right, so again, there is a right-angled triangle here. Geez, I don't think you're going to see that on the test, are you? Totally. All right, so I'm going to have to go and figure out my slant height first using the Pythagorean theorem. All right, and again, the important thing with the Pythagorean theorem is finding out your hypotenuse, which again is always across from the right angle, so that happens to be S. So I'm going to have an S squared is equal to the other 2 sides squared. So I have an 8 squared plus a 6 squared. All right, so I go and do some math here. So I have S squared is equal to, okay, 8 squared, 8 times 8 is 64, plus 6 squared, which is 36. 6 times 6. I put those 2 together, 64 plus 36, 100. All right, and again, I got to get rid of the S, the little 2. The only way to get rid of the little 2 is to square root, and the square root of 10 is, or of 100 is 10. Kind of gave it away there. There we go. So I put it in there. All right. Again, I like to label my diagram. I have the 8 And I have a 6. This is going straight up from the bottom to the top, so that would be my height. All right, and down here from the middle of the circle to the edge, that's my radius. All right, I got everything I need. Time to substitute in. All right, so we have surface area is equal to pi, which is, again, 3.14, times r. Again, I'm looking at my diagram. That's the 6 that's going to be squared. I'll put that in. Times pi times r times h. So I have pi, 3.14, times r, which is 6, times s, which we found, right? 10. Okay. And I don't want to forget about the squared here, so put that in there. Following Bedmas, here we go. We have 3.14. I figure out 6 squared, which is 6 times 6, which is 36. All right, plus, we've got those things which I'm not touching because I'm just doing exponents on this line. All right, there we go. That out. All right, and then so now we got to do multiplying. So I get 2 pieces to multiply. I got my 3.14 times 36, and I end up with 113.04. Okay, plus I got 3 numbers multiplied, and I got 188.4. Okay, last step. Last example of this quad master for math, surface area. I put those two together. I'm going to get 200 and something. Oh, sorry, 300 and something. 301.44. We're dealing with meters. And again, we're looking at how many squares it would take to cover this object. And there we go. So it's 301.44 meters squared. And that, folks, is